Hello everyone. I'll be presenting a research paper, a survey on routing in anonymous communication protocols. The literature offers a broad variety of proposals for anonymity network designs. Several of these designs have been implemented and deployed, one of which is Tor network, which is used by billions of people. Tor network aims at concealing its users' identity and their online activity from surveillance and traffic analysis by separating identification and routing. This is an overview we'll be seeing in detail one by one. Introduction. As we all know, Internet has become a global communication platform for billions of users to perform their daily activities like social networking, communication, video calls, education, entertainment, and even in politics. The disclosure of data happens not only when the user intentionally posts information online, but also unintentionally by engaging in some online activity. This is especially alarming because non-expert end users cannot be expected to understand the dimension of collection of privacy and its associated consequences. As the widely deployed communication protocols protect only the message content, the end users are being tracked, monitored, and profiled for their personal information through targeted advertisements and even by omnipotent governmental surveillance. This proposal, anonymous communication system, have been proposed to mitigate the threats of communication surveillance. The first proposal was anonymous email service that was aimed at concealing who sent emails to whom. Anonymous routing protocol characteristics. The definition routing, it refers to selection of nodes for relaying communication through the network. For AC network, we need four building blocks, namely node management, transfer retrieval of node information to or by the decision routing maker, path selection, and path forwarding. Here, path selection is the main design component of AC routing protocol. AC network conceal the metadata. The famous taxonomy has four categories. The communication model, which describes whether it's single channel or multi-channel. Structure describes whether or not a node can be treated equally. State information, it describes where the topology information is maintained. And scheduling describes whether the information about the routes is maintained at the source or is instead computer on demand. Not all the finesse characteristics are important for AC routing. In overlay networks, which is a common design option, for many AC networks, the communication model is not appropriate. Design choices to anonymous routing protocol is inspired by finesse, so it has been remodeled as below. The network structure, which has the underlying network topology, characteristics of anonymous relay, and the connections between them. The routing information has route of an anonymous connection, and the third part, which is the communication model, it describes the entities that make the routing decisions and how these decisions are made. Network structure, topology, it tells the arrangement of routers, how the data flows, and the communication links between them. We think of the network as a graph in which the graph nodes represent the routers. The edge occurs between two nodes only if the routing strategy enables those two nodes to be connected directly as a part of same anonymous circuit. Networks of anonymity are classified into three groups: fully connected, mostly connected, and partially connected. Fully connected, when the nodes or can connect to all other nodes. Here, in further slides, please note of the symbol of every component that I'm telling, because we'll be constructing a whole anonymous circuit using these symbols. As I said, like fully connected, a node on an average should be able to connect to at least 95% of other nodes. Mostly connected, if its node can potentially connect to at least half of the other nodes. Partially connected networks node connects only to relatively a small subset. In the other hand, removing links may cause security problems such as linking two nodes from same IP family that could be easier to control by an attacker but may be advantageous to anonymity. The same holds for removing connections which would cause higher latency, which in effect would boost the efficiency of the device. Higher network topology connectivity leads to a greater tolerance to node failure, such as DOS attacks, that may have significant effect on anonymity. Connection type. Connection type describes the characteristics of connections between the nodes. It can be unidirectional or bidirectional. A connection is said to be unidirectional, like say, example emails, the data flow can be in one direction. That is, you can just forward the mail. Advantages of this is it's less vulnerable to timing attack, as the malicious code can only observe the data flowing in one direction, which is less informative for the attacker. Disadvantages: forward secrecy is harder to achieve because of short-lived session keys. Here, perfect forward secrecy, as in definition, it gives assurance that the session keys will not be compromised even if the private keys of the server is compromised. And another drawback is large number of nodes are going to be involved. Bidirectional. Such as web browsing, it requires the data flow in both directions, and the same connection can be used for sending back the response to the received message. Advantages here are forward secrecy is achieved. It leaves less overhead in terms of circuit construction, and the drawbacks here are patterns of the request and response are visible to all the nodes in the path, so it is vulnerable to timing attacks. Connection type synchronization. As synchronization by definition, a timing model for connection establishment and sending data. Here the types are asynchronous and synchronous. Asynchronous is when the user initiates links and relays of the message without any time synchronization with the other participants. So here, asynchronous systems are conceptually easier, and they place less limitations on the network participant operations. However, it leaks useful information for traffic analysis. Synchronization, as by definition, it's the timing coordination that exists between the network entities where they begin and end at the same specific time, and the messages are relayed at a specific time. It is, however, difficult to engineer a synchronous system, and we can get a secure and reliable time, which becomes an additional dependency. It also disables trivial end-to-end correlation attacks based on the start and end times of the connection. Symmetry. Symmetry describes whether the entities participating in the network are similar, or if they can take a different role and responsibility for routing the data throughout the network. And to achieve anonymity system to be more symmetric when all the participating elements have similar roles and responsibilities. It is less symmetric when all the participating entries have different roles and capabilities and trust assumptions. The roles are categorized into following categories. Peer-to-peer. End users operate as relaying nodes in order to use the AC network. The advantage of using peer-to-peer is that more robust to node failures as the new users also increase the capacity of the network. Client server end users are not expected to operate as relaying nodes in order to use the AC network. Advantage, more reliable and secure as the nodes are not run by the end users. Client software is run by the end user, which has a low cost in terms of resources. Hybrid end users may or may not use hybrid can operate as peer-to-peer or client-to-server. Topology nodes are organized with respect to routing. It can be flat or hierarchical. Every node, if it has the same rank, then it's characterized as flat. If the nodes have different priorities, then it's called hierarchical. Decentralization. It is nothing but the degree of decentralization for non-routing services. The semi-decentralized. Semi-decentralized includes one or small number of entities to perform routing. So high level of trust must be placed on these entities. Fully decentralized does not include any external entities that it needs to place trust on. So fully decentralized systems have a better distribution of trust. This is the diagrammatic representation of what we have talked so far and what kind of symbols are used for each and every entity. Routing information. Routing view decides the route of a connection. Network view. Routing decisions are made based on the completeness of the information. It can be complete view or partial view. Complete view is when the routing decision maker has a complete view. Drawback, it consumes significant bandwidth and network resources, so less scalability. Partial view. Routing decision maker has only a partial view. Advantages, scalability is improved, and drawbacks, fingerprinting attacks, an attack that is used to gather as much as information as possible. Updating. It is characterized into three, periodically, event-based, and no update. Updating is when the routing information is updated and the frequency is collected. Here, the frequency count that is taken, it should be periodically or event-based or no update. Periodically, the routing information is updated in predefined time intervals. Event-based, updates are triggered by events. And no updates, if you don't have any updates, you just represent it by X mark. So the symbols are given below. Communication model. Communication model describes the entities that make the routing decision and describes how these decisions are made. Routing type refers to the selection of nodes to determine a route. It can be source routed or hop by hop. Source router initiator selects the set of nodes that will perform the anonymous route. The initiator picks node that she trusts. Receiver anonymity is achieved when both the initiator and the receiver picks the first and the second half which meets at a certain point. Hop by hop. If the initiator only selects the first relay mode, which in turn picks the second, and the second picks the third, this goes on until the message reaches the final destination. It is similar to how a router behaves. This is also called as random routing. This hop by hop mitigates fingerprinting attack, as the initiator knows only a subset of nodes, or a connection may be routed throughout the whole network. Known algorithms like distance vector routing are disregarded as it offers some kind of predictability. Node selection refers to which nodes to be selected to be a part of the anonymous communication. Determinism. Selection can be fixed, that is deterministic, or be computed probabilistically, which is non-deterministic. Selection set says which nodes are eligible and which nodes are not eligible. Following out the types, it can be all nodes. Selection set may contain all the nodes, or security restricted subset in which all the nodes in a route must be in different IP subset, or network restricted subset is implemented if you want to avoid congested links or nodes, or user preferences and trust assumptions where the selection set can be user specific. Selection probability. Individual nodes are chosen. Types. The probability distribution that describes how the nodes are selected may be uniform. The probability distribution is weighted based on generic static parameters. Example, the bandwidth of the nodes. And the third one is dynamically weighted, which is when the probability distribution is dynamically weighted. Example, the node's response time. In general, the parameters are calculated in real time to be dynamic, and the unchanged parameters are called static. Uniform. It offers better anonymity and weighted, that is statistically weighted or dynamically weighted. When that feature is used, it improves the performance. Communication model scheduling. Scheduling means incoming requests are served based on some priority. It can be either fair or prioritized. Fair is when all the types of connections are treated same. Prioritized means certain connections are given priority over other. This reduces congestion and improves performance. It mitigates flooding attack, like say DOS designed to bring down a network or a service down by flooding it with large number of traffic. The symbols for the scheduling is given below. Performance and deployability. These are the metrics based on which the performance is calculated. Latency. It can be low latency, high latency, or mid latency. Low latency. No latency to the communication comes under low latency. Example, web browser. High latency. Supports all applications that can tolerate a certain delay between the request and the response. For example, email communication. Mid latency. Supports application that can tolerate a restricted delay between request and response. Example, file sharing. Communication mode can be connection based or message based. Connection based is state is maintained for exchanging multiple data transfers. Message state means no state is maintained for further exchange of messages. That is, when you are talking about short time relay message, you use message based. Implementation and code availability. Uh, with the tick or X mark, you say whether or not it is implemented or a code is available or not. We'll be discussing these 9 routing classifications one by one. Mixers. Messages are cryptographically transformed so that they cannot be traced back based on their content. Input messages are shuffled and the output messages are again shuffled so that attacker cannot establish a correlation between the input and the output message. The mix shuffles input messages within a batch and dispatches out. So every input messages is dealt within a batch and it is flushed out. The next strategy is mix selection strategy. In order to establish a trust, a system was proposed to relay messages through a fixed sequence of mix nodes called mix cascade. Deterministic node selection or factors like network's topology and user's trust can be used for mixed node selection. Messages are successively encrypted with public key of each mix in the cascade. When it is transferred from one mix to the next as shown in the diagram, the current mix decrypts and obtains the corresponding address of the next destination. This happens until the message is sent to the destination. To overcome a single point of failure in availability of mix cascades, free route mix networks are used. Different strategies are followed when selecting mixers for a mix cascade or for a path in a free route mix. Suppose say a situation like what if the mixers fail? What will it cause any other delay? Mixers issue something called as receipts for each received message. Once a mix has sent a message to the next mix, if it doesn't receive any receipt within a short period, it demands for a group of witnesses to resend the message and collect the receipt and forward it. But the problem here is the reliability depends completely on the witness. To overcome this, another model has been proposed in which the mixed nodes of a cascade acts as a witness of their own cascade. All the mixers submit their reputation score. A pool of mix is created from the top score and this pool is rearranged for randomness, and from this the users are allowed to choose the mix cascade for their messages. The next strategy is variations of flushing strategies. Here you need to know what a flushing algorithm is. Flushing algorithm or batching strategies specifies the precise timing at when a batch of collected messages is flushed out. We'll be talking about some terminologies of mixers one by one. Continuous mixers. Mixers that delay messages individually and lead to continuous flushing. Threshold mixers. Mixers collect messages until a certain threshold is reached. Timed mixers. Time restriction for flushing out. The above three mixers are vulnerable to low traffic. Pool mixers only flush out a fraction of message of a batch at the at each round and keep the remainder in the memory of mix or say pool for the next flushing round. Advantage: if average delay of the message is equal, then the pool mixers offer better anonymity suitable for networks with fluctuating traffic load. We review some of the mix protocols for applications like ISDN, telephone, web browsing, and even anonymous emails. We'll see that one by one. ISDN mixers. It maintains a constant traffic by using threshold mixers. To obtain sender and receiver anonymity, these ISDN mixers use two mix cascades, each built by the sender and receiver respectively, and they are connected either by a connecting mix. To achieve constant traffic, time slice is used that starts and ends the communication at the same time. For real-time internet applications, these ISDN mixers are used as web mixers. That is, it uses several mix cascades instead of two. These mixers transform the message cryptographically and reshuffle the order before flushing. Info servers maintains hardly mix cascade information where the user can select the mix cascade. Cache server has a copy of replies saved so that the web replies are sent back to the same route. Prominent applications of mixers: remailers. Babel. It aims at mitigating traffic analysis attacks by delaying only some messages of the batch. Babel implements intermix detours in which mix nodes pick a random sequence of mixes and relay the message through them before forwarding it to the next mix of the original path. The flushing algorithm, it uses time restrictions and threshold. A mix master. It is an anonymous remailer in which the mixers transform messages cryptographically into uniform sizes by adding random data at the end of each packet. It's just like padding. If a message is too large, then this mix master splits up the message. Weakness of this protocol is it guarantees only sender anonymity. Mixminion deploys a certain redundant and synchronized system of directory servers in order to guarantee equal routing information for all senders. It uses something called as SERP, that is single use reply blocks, in order to avoid replay attacks. How Mixminion aims at providing sender anonymity and recipient anonymity for email messages. The routing path is divided into something called as legs, with each consisting of half of the mixers. Sender chooses the first half and the receiver chooses the second half. In the first leg, the sender chooses the mixers and appends the SERP of the second leg. So while traversing of message reaches the last mix of the first leg is replaced by the SERP so that the traversing of message continues till it reaches destination. This is one of the famous routing protocol, onion routing. Here nodes are referred to as onion routers. And bidirectional channels or called circuits. This is suitable for applications with low latency AC networks like web browsing. The communication is encrypted in a layered fashion, and the OR removes the corresponding layer of the encryption and forwards the data to the next OR, and so on. The last OR forwards the data to the destination. As you see in the diagram, it is like removing one layer another till it reaches the destination. The first OR knows only the initiator's IP, while the last OR knows the destination. As you can see, the ORs implement the first in, first out strategy. This routing protocol is vulnerable to traffic analysis and timing attacks. Onion routing based protocols. This is an advanced of the existing onion routing. This involves a better security, efficiency, and deployability when compared to the onion routing. Routers can connect to any router from the Tor network except routers located in the same IP subnet space. Tor deploys trusted authoritative servers that has a list of all active Tor nodes. This list is called as consensus. From this list, user chooses entry node, middle node, and exit node. Suppose the first entry that the user picks is the exit node, the second entry is called the entry node, and the third entry becomes the middle node. It is arranged like that. In 2002, each user has maintained a list of 3 randomly pre-selected, so-called as GART, which is updated every 30 to 60 days. Further deployment in the routing policy is to disallow the same IP, that is the 16 subnet space. That is why, the revised version is the routers except the ones located in the same IP subnet space. Traffic analysis attack, which aims at decreasing the anonymity, was prevented by increasing the communication latency. For improving the anonymity, better weighting at the node selection is used. Scalability issue is tackled by giving the user only the information about the necessary nodes for path construction and hide the complete view of the system. Random walks, structured and unstructured DTH based protocols. First, what is random walk protocol? If node selection is hop by hop routed and random selection, it's called random walk protocols. Here we'll be seeing two, that is crowds and morph mix. Crowds, here each node in the crowd is called John Doe. Each nodes are connected to each other into groups called as crowds. The node that administers and manages is called the blender. When the user sends a request, this node flips a biased coin to decide whether to send this request directly to the receiver or to forward it to another node selected uniform at random. This continues until the message reaches the destination. Vulnerability of this protocol is because of the predecessor attacks. Morph mix. After an initiator selects the first node, she selects a witness for each hop. The node proposes a set of candidates for the next hop, and the witness is allowed to choose one from them. Advantages. Nodes can only propose nodes with different IP prefix in order to avoid path compromise. The initiator adds random delays to her communication before forwarding them in order to avoid guessing by the attacker. We'll be talking about DHT-based protocols in detail. As you can see in the diagram, distributed hash tables has a value and a key pair. For nodes, their IP addresses are hashed into keys. In the paper, they have suggested 3 lookup strategies to find the key. Kadamlia, locating the nodes based on their estimated distance using an XOR metric. Chord, using a clockwise circle metric where each hop of the lookup, the distance to the node is decreased, at least half, and pass tree, carrying out lookups based on the numerical identifiers. In further slides, we'll be implementing only the first 2 lookup strategies to find the key, that is Kadamlia and Chord. We will review some of the protocols that implement these. Salsa. It virtually divides node into groups which are organized in a binary tree. Chord is used for key lookup. This is mainly used to improve scalability. Toss, that replaces tor's node definition to DHT table by using randomly chosen key that is looked up in Kadamlia. Here, root certification is used to secure the lookups. Nissan, it uses iterative search to select nodes randomly through Chord. This aims at achieving high scalability. Octopus, node selection is carried out into 2 phases. In the first phase, the nodes are selected by the user. In the second phase, the last node selected in the first phase chooses the remaining nodes. Security is achieved by hiding what nodes are checked for anonymous paths that help to provide anonymity. File sharing. It is done by either Freenet or Gap. Freenet. The key design of Freenet is based on the storage replication and possible deniability. Files are stored multiple times at nodes. Each node has a dynamic routing table. The routing table is updated periodically for better performance. 3 methods are used for key construction, that is keyword signed key, signed subspace key, and content hash key. It works on 2 modes, that is OpenNet mode and DarkNet mode. In OpenNet mode, we'll be talking about few of the cases here. When a file request arrives at a node, and if the file is not stored locally, then the node looks up the node with the nearest key and forwards the file request to the corresponding node. The node receiving the request does the same process till the file is found. Case 2. What happens if the node is not responding? If the node is not responding, then the request is sent to the second nearest key. If that is also not responding, then it is sent to the third nearest key and so on. And what happens if the file is not retrieved at all? That is our case 3. If it's not retrieved, then the search is aborted. This OpenNet is prone to many attacks. The next mode is DarkNet mode, in which the user chooses the nodes from her trusted nodes. The relaying nodes only know their predecessor and the successor in order to maintain privacy. Gap. It aims at providing requester and responder anonymity for a file search or a file sharing. It has an option called dropout. This option is so special because if the node has too much load, it just drops out. The file request can either be sent to a newly selected node or to existing connection. Gap uses time-line restriction in order to avoid routing loops. DC networks. DC nets offer non-interactive anonymous communication using secure multi-party computation with information. It guarantees sender anonymity and secure messages, but all the participants must participate for the final outcome. Here, every participant outputs message that is XORed with the key. Here, the key is nothing but a pairwise key shared with the other participant. All the outputs are then broadcasted. The encrypted messages are combined in which the key cancels out and the message is revealed. As you see in the diagram, which is a ring topology, a participant with the other participant will have a pairwise key and the operation is performed. Challenges here are the first one, the message transmission or avoiding collisions. Second challenge is if two users submit reverse bits, they cancel each other out and the disruption remain undetected. So malicious participant can adapt their answers to other participant answers to avoid being detected. So this is a great vulnerability. DCNet does not prevent any disruption such as blocking participants from sending message, hence anonymous DOS attacks are possible. And it is also vulnerable to Cybele attack. Here, Cybele attack is a kind of security threat on online system where one person tries to take over the entire network by creating multiple nodes. For better scalability, Herbivore is built on top of DC nets. Participants are broken into smaller groups called cliques. We'll be talking about inter-click communication and intra-click communication. Here, for inter-click communication, the cliques are connected to each other in a ring topology, like in the diagram that I showed earlier. This is the inter-click communication. With the clique, the participants are organized in a star topology where the center node relays all the messages between the members of the clique. Advantages of Herbivore is a message can only be traced to a clique but not to the corresponding sender or receiver, thereby providing anonymity. Disadvantage: star topology makes the design vulnerable to DOS attacks. Dissent, which dining cryptographer shuffle send network. It is built on the top of DC network. This solves the collision problem. Dissent consists of two sub-protocols, namely shuffle protocol and bulk protocol. In bulk protocol, each member creates an assignment table for each other member, so-called the message descriptors. The shuffle protocol is used to shuffle these message descriptors. The shuffle protocol functions similar to what we spoke earlier, that is mixed cascades. In descent, go and no-go messages and plain phrases are used to minimize devoice attacks, which recognize collisions and malicious participants. Drawbacks: unsuitable for interactive and low latency applications like web browsing. Extended descent is an enhanced descent version where the network consists of several nodes, uh, which are participant nodes, and only one server node. The group of members share keys with these server instead of each other, thus improving the scalability. At least one of the server needs to be honest in order to prevent compromises. Advantages: it is suitable for low latency applications like web browser. Miscellaneous protocol. It is the applications are Tarzan and I2P. Here, I2P, I'm not sure about the abbreviation. It can be Invisible Internet Project. Okay, anyways, Tarzan nodes do not implement any mixing strategies and simply forward the incoming traffic. I2P is aimed at enabling anonymous communication between two nodes within the I2P network. Floodfill nodes has router contact communication as well as the destination contact communication. Here, communication channels are referred to as tunnels. The outgoing traffic are called outbound and incoming traffics are referred to as inbound. There are two types of tunnels in I2P. Client tunnels and exploratory tunnels. Client tunnels are used for application traffic, whereas exploratory tunnels are used to send administrative information. Garlic encryption. It is much similar to onion encryption, but the only difference is multiple messages may be contained in a single garlic message. Discussion. Routing features, commonalities and differences. We will be talking about these 5 protocols. I'll be showing the diagrammatic representation in further slide. Okay. The Mixnet based protocol, as you can see in the left hand side, there are so many protocols that comes under Mixnet based protocols, and the classifications that we discussed earlier, that is network structure, routing information, communication model, and performance and deployability. So we'll be representing in terms of symbols here. Let's go one by one. In Mixnet based protocols, existing routing strategies can be classified into free routes and mixed cascades. A connection exists between two nodes or not is based on the routing of the message. So in the figure, you can see that only web mixers and restricted routed mix are partially connected. Partially connected or represented by something C. Under the topology column, you can see a C, right? That is partially connected. So for web mixers and restricted route mix networks, it is partially connected, but for rest others, it's fully connected. Recall in Mixmaster and Mixminion partially uses time restrictions, but here due to low traffic, we consider asynchronous. So synchronization will be asynchronous for Mixmaster and Mixminion. For Xiaomi mixers, that is the first one of the Mixnet based protocol, the node management is complete. That is, you can see a full shaded circle, right? Mixmaster has partial view, whereas Mixminion has a complete view. For Shamion, since all mixers are chosen for a single mix cascade, the it is deterministic. So the determinism is represented by a tick. All mixed cascade protocols are high latency, which is represented as H, but except for ISDN, real-time mixers and web mixers that are designated for low latency applications, so it is represented with the symbol L. Next, at the bottom left, you can see many onion protocols, right? So, as we all know, onion protocols exhibit homogeneous routing design. So, all are same except for network view, scheduling, and selection probability. So, only these columns vary, but rest others are same for all the protocols that comes under onion routing protocol. DHT based protocols. We'll see some examples in this. Selection probability, as you can see in one of the column under communication model is selection probability, which is uniform except for freenet and GNUnet. DHT based protocols or message based, the symbol is like a email message. You can see under performance and deployability, under the column communication mode, you can see that symbol. For DHT based protocols, it is message based except for TORS, SALSA, and AP3. Crowds is semi-decentralized because routing information of the nodes is distributed by a blender, which is a central entity. Morphics is fully decentralized. In Morphics, the network view is partial, so the witness does the node selection here. The network view is complete in crowds. The first two are crowds and morphics. From the left, when you can see, it's partial for morphics and complete for crowds. The next is DC nets. In that, we'll talk about the herbivore. In herbivore, participants are organized in star topologies, which are then connected in a ring topology. Do you remember the diagram where I showed here the ring topology? Yeah, we'll be discussing about this. This results the nodes to be hierarchical because star and then it's connected in a ring. The network structure is partial view. The explanation is given in further slide, like why it is partial view for hierarchical structure, which we'll discuss in upcoming slides. And the last one is miscellaneous protocols. The original version of Tarzan had a partial connected topology. Later versions are made to fully connected. So you can see like a square box, right? So that's fully connected. The I2P has unidirectional connection, whereas Tarzan has bidirectional connection. Correlation, conflicts, trade-offs, and application. We'll be talking about, few of the correlations between see topology and routing features like this, like one column topology and the routing type from the communication model. We'll check whether if there is any correlation or not. Okay, so no correlation between the topology and routing features. That is, say like roles and decentralization. That is why the topology is only based on the connectivity of the relaying routers rather than the users or admin. The second is correlation between hierarchy and topology of AC networks. Hierarchical AC networks does not have a fully connected network structure. Remember, we discussed in DC net based protocol in herbivore, where the participants are organized in star topology, which are then again connected in a ring topology. The results, this results the nodes to be hierarchical, right? That is why the network structure is partial. The third is correlation between the topology and selection set. That is, restrictions in the selection set will lead to reduced connectivity, which will lead to reduced topology. That is partial topology. Fourth is flushing algorithms will also influence scheduling. Like say, pool mixers have prioritized scheduling. Fifth is correlation between scheduling and latency. Yeah, that's obvious. Sixth is correlation between latency and communication mode. Because replies are not going to be sent in a short time. So high latency AC networks will only need, message-based communication. The figure below, it has the table description of, the applications like Mixnets, onion routings, random walks, and DCNet. Mixnets are designated to be secured against the traffic analysis, but they are vulnerable to flooding attacks. So the challenges here for the Mixnet is they are vulnerable to flooding attacks. Tor network from the onion routing can secure against local adversaries, but they are vulnerable to traffic analysis attack. So the challenge here is timing attack. Random walk protocols has fully peer-to-peer. This affects the usability of the protocol, which in turn decreases the number of users, thereby reducing the anonymity. So if there are only few users, then the attacker can easily find out. The last is DCNet, where all the users or nodes need to be honest. For better scalability, it is used in applications at a small scale. Conclusion. Our classification defines which routing decisions to be customized to security, anonymity, scalability, and performance that are appropriate for particular application of AC protocol in the question. For anonymous communication, it is very hard to have all these four factors, that is security, anonymity, scalability, and performance. And also, it is very difficult to distinguish the various routing aspects from one protocol to another, like partial view supporting hop by hop. That's the end of the presentation. Thank you for watching.